Okay, in this video, we're going to look at integration involving natural log and e. So let's look at two rules. So this is just the integral of e to some power with x in it, ax plus b. And right now, pay attention to the fact that we're looking at when x is linear. So when x is to a power of 1 here. Because we're going to look at some different ways to integrate when x is a different power. But for this, the integral is everything stays the same. So e to the ax plus b divided by the number in front of x. So a divided by a. And then of course with the integral we always put plus c or plus k for our constant that could be there. Now this is fine, this is the integral, but you might see me also write this, instead of writing the a underneath, I sometimes write this as 1 over a with the e to the ax plus b power next to it. And so either form is okay. So let's look at this bottom rule. This is 1 over ax plus b. And so notice that down here on the bottom, again, x is linear, so that's important. This has a power of 1. But this is basically going backwards. Our answer is going to have a natural log in it, because when we take the derivative of a natural log, we get the derivative of the inside over the inside. And so when I have linear x on the bottom here, so ax plus b, my integral is going to be the natural log of the absolute value of the inside divided by the number in front of x. Okay, again, these are linear. If they're not linear, we're going to look at other things that you might consider. But so over a, and then we put plus c. Again, this can be written as 1 over a times the natural log of the absolute value of ax plus b plus c. Okay, so that's my integral of a form like this, and then this is my integral of e. So let's look at some examples. Okay, so on this first one, we have 3 times e to the power of 5x. I do want you to understand that this 3 could be moved out front. It's really just 3 times the integral of this. And so the integral of e to the 5x is e to the 5x divided by 5, that number in front of x. And so really I have this 3 out front. I'm multiplying the 3 by it. You can do it from here, or you can rewrite it like this. It doesn't matter. And then I need to put plus c. And that's it. Why don't you take a minute, pause the video, and try this one? Okay, let's check your answer. So on this one, we're going to have everything stays the same divided by the number in front of x, which is 2 in my power, plus c. And that's fine, that's it. I could also write this in this form, just so you're used to seeing that depending on what we want to do with it, okay? Okay, so let's look at this one. This is a definite integral. We have bounds here, so hopefully you remember how to do that. But the initial step is the same. I want to integrate this inside part. Again, you could rewrite it with the 6 out front, but we don't need to. I'm going to integrate this, and it's going to be everything stays the same divided by the number in front of x in my power. And then when we have a definite integral with bounds, we don't put plus c. What we're going to do is we're going to evaluate this from 1 to 5. And you can do that. I like to simplify this first. So 6 divided by 3 is 2. So I can simplify it down to this. And then I plug in always my top bound first. So when I plug in my top bound, where I see x, I'm going to have 3 times 5 here, which is going to be 15. And then we subtract what we get when we plug in our bottom bound. So when I plug in 1, I'm going to have 2e to the power of 3. And that's really my answer. That's an exact form. If I wanted to go ahead and simplify and put these together with a calculator, you are going to have a very large number, which you see there. So either way, if it says exact, I would have to stop here. But otherwise, I can get this with my calculator, and that's fine. All right, let's look at this one. Same idea. I want to integrate first. So I'm going to integrate this, and everything is going to stay the same, divided by the number in front of x in my power. So you have to be very careful about that. And then I want to evaluate this from my lower bound to my upper bound. Again, personally, I like to simplify first. 4 divided by 2 is 2, so I get 2e to the 2x. And I'm going to evaluate that from natural log of 2 to natural log of 4. Now, when I do this, I'm plugging in these bounds to where I see x, and I'm always plugging in my top bound first. So I'm going to get 2e to the power of 2 times the natural log of 4 minus the same thing with my bottom bound plugged in, which is going to look like this. Now, you could do this in a calculator, but it's important to understand your log rules as well. Here, I could actually move these 2's to the power. We know that with the log rules, natural log as well, so that 2 in front could be moved to the power. That would give me 2e to the natural log of 4 squared, which is 16, minus 2e to the natural log of 4. And then remember that we talked about this, and when e and natural log are next to each other, my result ultimately is just going to be the 16. So this becomes 2 times 16 minus 2 times 4. And when you do that, you get 24. But if you had typed this into your calculator, you would have gotten 24 as well. Okay? Okay, so this is our other rule that we learned. So notice that you see an x on the bottom, and x is linear. So again, you can rewrite this as 4 times the integral of 1 over x. So know that you can do that, and then this should look familiar to you because this 1 over x is actually the derivative of the natural log of x. So if we're integrating, we're obviously going backwards. We're going to have the 4 times the natural log of the absolute value of x plus c. And we put absolute value because we know we can't have a negative value here of x inside of natural log. So this is my integral. Here, again, I have a linear x on the bottom. So I'm going to do 1, since 1 is on the top, 1 time, so we don't need to write that. The natural log of the absolute value of the bottom divided by the number in front of x plus c. And then you'll see me in class a lot rewrite it as 1/3 times the natural log of the absolute value of 3x minus 1. Okay, that's really all there is to it. So I want you to take a minute and pause the video and try this problem. Okay, so looking at this one again, you could take the 2 out front, but this number on the front is really just getting multiplied by the natural log of the bottom here. So 2 times the natural log of the absolute value of 5x plus 3, and then remember, you cannot forget to divide by the number in front of x, which is 5. And again, I'm going to write it like this most of the time. Either way is fine. But that's my answer. Okay, one more time. Take a minute, pause the video, and try this one. Okay, on this one again, we have a 2 on top, so we're going to do 2 times the natural log of the absolute value of 3 minus 2x. Be careful because you are now dividing by a negative 2. That is the number in front of x. 2 divided by negative 2 simplifies to negative 1. So I can simplify that down a little bit. And that's my answer. Okay, looking at these last two, this one again, guys, it's just that I'm going to plug in some bounds here, okay? So I'm going to plug in 1 and I'm going to plug in 4 after I do my integration. So why don't you take a minute and go ahead and pause the video and try this one and get as far as you can. Okay, so on this one, again, starting with your integration, I have 2 times the natural log of the absolute value of 3x minus 4 divided by 3, and we're going to evaluate that from 1 to 4. Okay, now I'm going to go ahead and plug my top bound of 4 in, and I'm going to go ahead and write this as 2/3 times the natural log. When I plug 4 in, I'm going to get 3 times 4 is 12, minus 4 is 8, and since 8 is positive, I don't need the absolute value anymore. Minus what I get when I plug in a 1, which is going to be 2/3 times the natural log of 3. 1 times 3 is 3, minus 4 is negative 1, and that's negative, so I definitely need that absolute value. Now let's simplify this a little bit further. So this negative 1 inside absolute value means positive 1, and the natural log of positive 1 is 0, and 0 times 2/3 is 0, so that whole thing right there becomes 0. So really all I'm left with is 2/3 times the natural log of 8. And I could leave it like that as an exact answer. I could get a decimal, which is 1.39. I could use rules of natural logarithms to rewrite this a little bit if I wanted to match something up, but either one is fine, unless specified, of course. Okay, I want to look at this last problem, and this one, I want you to, like, on your notes, make a note or a star. This is the one that are going to get people on a test. Because notice the bottom does not have a 4x plus or minus something. It does not look like this bottom here. So this is just 4 times x. And if you go about doing this exactly like you did these over here, you're going to have the wrong answer. Because what I actually want to do is I want to think of this as 1/4 times 1 over x. So that's a constant there that I'm multiplying by. And I can even bring that 1/4 out front if I wanted to. It doesn't matter if you bring it out front, but you have to recognize it. You have to recognize that this bottom does not have a plus or minus anything. And so when you do it, you're actually going to have 1/4 times the natural log of the absolute value of x. You're not going to have the 4x inside your natural log like you do over here, okay? Because I don't have a plus or minus. Over here, I don't have a common factor, so I can't take anything out. So I have to leave it the way it is. But if you don't have a plus or minus here, then you are going to definitely take this 1/4 and understand that it's 1/4 times 1 over x. This is now going to be evaluated from 3 to 5. So I'm going to have 1/4 times the natural log of 5 minus 1/4 times the natural log of 3. Now, you could do this in your calculator and you could get a decimal answer, but we know that on our test, many times it asks us for an exact answer. And so they're going to want you to be able to simplify this using your rules of logarithms. I can take out a 1/4 and I have natural log of 5 minus natural log of 3. And I know that with logarithms, when I'm subtracting these numbers, it can actually be combined into a single log where I do 5 over 3. So this is actually the same as 1/4 times the natural log of 5 divided by 3. Now I could do other things with this, but usually we'll leave it like this. But understand that if you're asked to get an exact answer, you need to be able to combine these to get something along these lines, okay? Otherwise, you can give it as a decimal answer unless you're asked specifically for an exact answer, okay? Hope that helps. If you need to rewatch it, do so. I will see you in class.